Supervised versus unsupervised learning, a comparative analysis. Introduction. In the realm of machine learning, the methods by which algorithms are trained to make predictions or infer mappings are crucial. Two of the most prominent approaches are supervised and unsupervised learning. While they both fall under the umbrella of machine learning, their methodologies, applications, and outcomes differ significantly. Supervised learning. Definition: supervised learning involves training a model on a labeled dataset. This means the algorithm is provided with input-output pairs, and it learns a mapping between the inputs and outputs. Training data requires a dataset where the outcome variable, or label, is known. This dataset serves as the teacher guiding the model towards the correct prediction. Applications. Classification: assigning input data into categories, example spam email detection. Regression: predicting continuous values, example house price prediction based on various features. Advantages. Predictive accuracy is often higher since the model is trained on known data. Clear feedback mechanism allows for model optimization. Challenges. Requires a substantial amount of labeled data, which can be time-consuming and expensive to obtain. The model might overfeed to the training data, making it less generalizable to new, unseen data. Unsupervised learning. Definition: unsupervised learning involves training a model without labeled data. The algorithm identifies patterns and structures from the data itself. Training data uses datasets without any predefined labels, allowing the model to work freely and find relationships on its own. Applications. Clustering, grouping data points based on similarities, example customer segmentation. Dimensionality reduction, reducing the number of variables in a dataset while preserving its structure, example principal component analysis, PCA. Advantages. Can handle vast amounts of data since it doesn't require labeling. Useful for exploratory analysis to find hidden patterns or groupings in data. Challenges. Predictive accuracy might be lower since there's no clear feedback mechanism. Interpretability can be challenging, especially when the algorithm finds complex structures in the data. Comparative insights. Data dependency: supervised learning is heavily dependent on labeled data, while unsupervised learning thrives on unlabeled data. Goal: supervised learning aims to predict outcomes based on input data, whereas unsupervised learning seeks to understand the underlying structure and relationships within the data. Feedback mechanism: supervised learning benefits from a clear feedback loop, allowing for model refinement. In contrast, unsupervised learning lacks this direct feedback, making model evaluation more subjective. Conclusion. Both supervised and unsupervised learning offer unique advantages and cater to different needs in the machine learning landscape. While supervised learning provides a more directed approach with potentially higher accuracy, unsupervised learning offers flexibility and is invaluable for exploratory data analysis. Choosing between them depends on the specific task, the nature of the data at hand, and the desired outcome.